I'm Chris Lee. I'm a respirologist at St. Michael's Hospital in Toronto. Today we're going to be talking about an introduction to respiratory control. I have no relevant disclosures for this video. In terms of the end-of-week learning objectives that are relevant here, we're going to be talking about some of the following things. Now, a few of these things will be addressed in this video, but many of these will be addressed in some of the large group lectures that you're also having on this subject. The end-of-week learning objectives are: apply the concept of feedback loops to the control of breathing, describe normal ventilatory responses to CO2, O2, and change in pH, describe the effects of sleep on the respiratory system, recognize the effect of REM sleep versus non-REM sleep on the respiratory system, and describe the influence of non-REM and REM sleep on respiratory physiology. For this particular module, we're going to be concentrating on just a couple of things. We're going to describe the concepts of positive and negative feedback loops, and then we're going to try to apply that concept of feedback loops to the control of breathing. In terms of feedback loops, they have three critical pieces. The first piece is the central controller. The second component of a feedback loop is the sensor, and the third component is the effector. The sensor provides input to the central controller, and the central controller then takes that input and processes it and leads to an output to an effector. The effector then provides some feedback back to the sensor, completing the loop. Let's talk about an example of a feedback loop using the speed of a car. In a car, the sensor is the speedometer, whereas the effector would be the accelerator, and the central controller would be the driver. So if we have your speedometer, the accelerator, and the driver in place, this is how the feedback loops. Let's say the driver decides that the car is going too slowly. The response, in terms of the output from the driver, would be to hit the gas pedal. And that gas pedal then translates into motion in the accelerator and the car going faster. This leads to the speed of the car increasing as detected by the speedometer. And this information goes back to the driver. Now, if the driver decides that this is fun and we should go faster, then the driver will actually increase the output and the car will go even faster. This would be an example of a positive feedback loop. In a positive feedback loop, the response of the controller is to actually further augment the action of the effector. And the result of this is a divergent runaway behavior. And in the case of the car, this is the driver deciding to push the car faster and faster until something bad happens. Let's go back to that same scenario and look at what might happen if the driver had a different response. So going back to the situation where the driver thinks that things are going too slowly, the driver will hit the gas, the car will start to go faster, and the speed of the car will start to increase. But if the driver decides at this point that this is too much, he'll say, "Whoa, car's going too fast. We have to back off." And so this leads to a different output from the driver. And as a consequence, this is what we call a negative feedback loop. So in a negative feedback loop, the response of the controller is to actually reduce the action of the effector. And this has a different effect. This has more of a stabilizing effect. This will promote equilibrium as opposed to divergent runaway behavior. Negative feedback loop. The respiratory system is also a feedback loop. In the respiratory system, the sensor is actually some receptors, and we'll talk a little bit about what those receptors are. The effector is actually breathing muscles. And the driver, or the central controller, is your brain. There are several parts of the brain that are involved in respiratory control. In particular, there's the brainstem, and within the brainstem, two particular areas called the medulla and the pons. Up higher is the cortex, and so the cortex also of the brain also has some control over the respiratory system. And finally, the limbic system in the brain also contributes to respiratory control. In terms of receptors, there are a number of receptors that act as sensors in this feedback loop. So we have chemoreceptors, and the chemoreceptors can be divided into central and peripheral chemoreceptors. And then there are lung receptors, which respond to mechanical stimuli. And so you have stretch receptors, irritant receptors, and J receptors. We're going to talk a lot about these receptors in your large group lecture on this subject. And then finally, in terms of breathing muscles in the respiratory system, you have the diaphragm, the main breathing muscle of inspiration, but you also have some help from accessory muscles, including the scalenes and the sternocleidomastoids. So in our large group lecture, we're going to take all of these components, we'll talk a bit about what they're made up of, and get into some specifics about how these things control breathing, including PO2 and PCO2. So here are the key messages from this short introductory video. Number 1, feedback loops have a sensor, an effector, and a central controller. Number 2, positive feedback loops augment the action of the effector, while negative feedback loops tend to reduce it. The respiratory system is a negative feedback loop with chemo and lung receptors as the sensor, muscles of respiration as the effector, and the brain as the central controller. So, the module objectives that we've accomplished, by now you should be able to describe the concepts of positive and negative feedback loops, and apply the concept of feedback loops to the control of breathing. Thank you for your attention. We'll see you in lecture.